The control circuit board from the regulator. It looks pretty complicated, but to tell you the truth, most of the components on the outside of this black blob here are just for feeding signals into the main control chip or taking signals out of it and using them to either run the motor or turn lights on or whatever they have to do. So this first one over here labeled U2 is just a simple 5-volt voltage regulator. This is usually the chip that goes poof as soon as you put anything more than 7 or 8 volts into the board, and I would recommend replacing it with a 5-volt buck boost converter if you plan on increasing the voltage to the regulator, the blaster, not the chip. Which means that a lot of the burned out regulators are actually really easy to fix. You just need a voltage converter. The next chip here, which I don't think is necessary, is I'm not sure of the exact voltage, but it's a power on reset, which basically makes sure that this chip doesn't turn on unless enough voltage is applied here. And then that feeds 5 volts into this rail right here. Now that leads into the main chip here. The first set of wires right here is the trigger wires. This is where the wires for the main trigger are connected, and that sends a signal down this wire to the board. This is just a couple of capacitors, I think, for power supply stability. Let me think now. That's another 5-volt lead. Everything connected to this line right here is just a 5-volt connection to something. That's the 5-volt connection to the infrared sensor inside the barrel. The magazine well. And this is the output from the sensor that leads into the board. There's a little wire that leads around back to here. These 2 points right here are connections. I think these 3 actually are all connections to the select fire switch. This right up here are the wires going to the empty indicator. Let me see. I drew a diagram over here of where most of the wires go. You can see there's a wire that goes through a resistor up to the empty LED negative lead of the LED, I mean. The resistor is probably just there for stopping it from getting too much voltage. The infrared LED negative wire is also over here. That just has to be powered but only when you pull the trigger. Next is this complicated looking mess over here. Just a second. There we go. There's not actually much to this area here. This part right here is the transistor that's used to control the flywheel motors. Yes, that puny little transistor has all the current for the flywheel motors going through it. You should definitely bypass that if you can. Resistors, etc., the flywheel circuit, and as far as I can tell, the flywheel circuit isn't actually controlled by the main board at all. The main board supplies power so that the signal wire comes out of the main board, but all it does is connect this wire right here to what I assume is 5 volts to allow this transistor to turn on to power the flywheels. The rest of this stuff over here is mostly part of the pusher control circuit. As far as I can tell, the way that works is that the board over here controls this one transistor, which connects the motor tab to negative, which allows it to run. Then there's another set of transistors over here. I don't exactly understand how this part works, but somehow it will turn on this transistor right here when the motor needs to brake, and that will feed the power from the motor back into itself, or however motor braking works. The point is it connects the 2 sides of the motor together when it's not running. And that's basically all there is to it. This is just an inductor coil here, again for power supply stability. If you put in a buck boost converter, it should have that added stability built into it already. A couple of unused traces of unused pads over here. Power in and out. Anything that's connected to this line right here is just connected directly to negative. Now the positive wire going into the board is right here. There's also one over here that comes back from the flywheels, I believe. Basically nothing on the board is connected directly to the maximum voltage. It all goes through the voltage regulator over here, which again can't handle very much power going through it. It's a really small voltage regulator, and you're better off just using a buck boost converter that can actually handle it. Just to be clear, this is the negative wire. This is the power output wire from the regulator, and that's the power input wire, or voltage input I should say. So if you want to replace it with a voltage regulator, those are the 3 pins you need to know.